Good morning, everybody. Just checking in, and I hope everyone's doing as well as possible. Today we're going to take a look at Chapter 9, Bivariate Tables. And the main idea of what we're going to be looking at today is comparing two variables, hence the bivariate title here. And today it really isn't as difficult maybe as some of the other ones. It's a lot simpler. We're mostly going to be looking at concepts. So I think it'll be a little bit easier, especially once we get into the final product, the final paper, the final homework assignment for this. So as we look at the homework assignment, I think a lot of it will basically be conceptual, and it'll be just us taking a look at tables. So throughout this, there's going to be two main things we're going to do. I'm going to go through the basics, with the common practices of looking at two variables at the same time, a bivariate, meaning two variables. And in the second half, we're going to take a little bit closer look at how these might apply in actual research practice. So I'm going to take a look at a few examples from the book that I think are pretty useful because they actually look at the bivariate tables and they pull the data from the survey data that we'll be looking at for our own research projects. So those ones will be useful because they actually go through and we actually see what the research process looks like. And I guess a third subpart of that is going to be looking at two more characteristics of bivariate tables, just some errors that people commonly run through. So it's a pretty simple section. You'll start to see that as we take a look. And just kind of follow along and pause as need be, and rewind and go over sections. But I'll start going through this first part, and we'll look at a few of the examples. So the basic idea of bivariate tables is just like anything else in statistics, is it's a really good way to kind of pull your data together. Because a lot of what we're doing, like we've been talking about, is descriptive statistics. We're looking at the characteristics of variables, how they relate with each other, and what sorts of information we could pull out of them. So this is just another example of taking complicated tables of data and pulling it into something a little bit more simple and easier to understand. So I'll take a look at the first example here to see what I'm talking about. But before we get into that, just a few techniques to acknowledge. And if you have the book, I'm looking at 236 here, page 236. So one of the first phrases to take a look at is cross-tabulation. And simply all that is really saying is we're going to be taking a look at two variables side by side. And it's called cross-tabulation because you're basically putting two tables together and analyzing the relationship between the two. So honestly, it's not necessarily if there's a right or wrong answer as you look at these, but it's more what the best answer could be. And being able to provide evidence for that. Okay. So there's a table we're going to take a look at. So to create a table, basically you're going to take a look at what the variables are saying. Okay, so in this particular case, looking at two characteristics, somebody's race, whether they're white or black, and whether they're homeowners. So basically each one has its own column, and you pull the information together. So it's actually, before we jump into that, let's take a look at what this looks like. So here's two tables. They're saying the same thing. As you can see, one very complicated and the other not so complicated. So basically what they did is they took this first chart and they made it a little bit less complicated. So you went from here over to here, and they took the same information, homeownership, and then they took the respondent's race and attached it over here. So basically what you would do for this, and maybe this is where you might pause it and actually go through, and count them, but let me just go through a basic rundown of how they created this. So if you look over here in the very far left, they had the respondent. So basically you see that there's 20 people total here. And then so what they did is they took each respondent and then put them in the column. So over here, by creating these two columns here, because it's bivariate, two variables, they took black and white and own or rent. Because if you went through the chart over here, you'd see basically there's only two different types of answers. And they counted them up. So for instance, the first cell here is 3, because that's the way they took the black respondents who owned their homes. So they went down the list and counted all those people up and got 3. And similarly, they did white respondents who owned their home. They went down, counted everybody up on the left table, and found 7. And same thing for rent. I found 6 and 4. Okay? So basically then, what you end up with in this section is going to be a summary of what is on the other section. And as you can see, it's much easier to pull characteristics out of this to get main ideas out of this. And before we move forward, and you might pause it here and look back at this again, fully absorb this. There's also 2 additional rows and columns. These are called, let's see, these are called marginal rows and marginal columns. And basically they're called this because they're in the margins. They're on the outside of the chart. What you'll notice with each of them is that they are the totals from the whole section. So for here, for instance, the 9 at the bottom is because they took the total from everyone who rented and came up with 9. And similarly over here, they took everybody who was white in this category and got 11. And you could also do the same thing going across. So 7 plus 3 is 10. 6 plus 4 is 10. And what you end up with the very end here, I'm going to underline this 20 here, should be your total. So this is the total number of people, which would also match if you look to the other chart, the total number of 20 people. And this is the addition of all columns, of all rows and all columns, the total number of people that answered this question, or N. As you can see over here, total cases are N. There's always our total number of people. So just to kind of clear this up a little bit, then. So again, they just took each respondent and they counted them up and then made this chart about it to make it a little bit easier. Again, different characteristics is bivariate. So in this case, it's race and home ownership. And they just counted them up, and then the marginals are the things at the bottom and the far right are the totals of each category. Okay? So what can we do with this? You could take a look at this, like if I were to ask, for instance, you could ask questions like what number of white respondents rented their home? And you could say 4. What if I were to ask what number of black respondents owned their home? You would say 3. Right? What were the total number of white respondents? You look here and you'd see that it was 11. Right? So it's a lot easier to pull information than if you were to look at this one. And that's the main idea of this whole thing, is to make it a little bit easier to understand and a little bit easier to analyze. Okay. I'll take a look at this, so we'll go look at a few more definitions. So here's the other thing you could do, is you could also turn this all into percentages. So if you look at the last one, it was just numbers, whereas this one's percentages. So again, if we were to clear this up a little bit, If we look over here, for instance, essentially what you're doing is you're taking whatever number you had here and dividing it by the total. So in this case, if you look back at the old chart, it was a 3 over 9 total, which equals 33%. Same thing with any one of these. Like here, out of 11, if you went to the other section, you could see that it was 7 divided by 11, which is about 64%. So each one of these are just ways of coming up with the percentage. You just divide it by the total. And you could do that for each one of these categories. You take this one divided by the one below it. So you treat the top one as numerator, bottom one is the denominator. Let's do one more. So for instance, right here, white respondents that were renting was 4 over total of 11. So 4 divided by 11, and you end up getting about 36%, which is where that number comes from. And it's just a conversion. So again, if you were to ask questions like what percentage of black respondents rented their home, you could say 67%. What percentage of white respondents own their home, you could say 64%. So just again, easier way to get the percentages and the information from here. I'm going to pull up a little bit before we move forward. So here's a bit of the characteristics of the bivariate table. So if we were to look in here, this is all coming from page 237 of your text if you have it. But basically there's a few characteristics here, and we've seen these in action. So this is just a recap. So each one has 2 dimensions. In this case, as we saw, one was for race and one was for homeownership. So that's the 2 characteristics. The intersection of the row and column is a cell. So we saw each one of these things by definition. A cell refers to each one of these little sections where the row and column intersect. Sorry about that. Where the row and column intersect. And this would be a 2 by 2. So basically you're describing the rows and cells. So 2 rows and 2 columns equals a 2 by 2 table. And in this whole section, we're only going to be looking at 2 by 2s. We'll take a look at a few other ones in the next chapter. And that's about all the characteristics you're going to need for this. So just keep this section in mind as far as overall definitions you might want for later on. So take a look at this. These are the definitions you might need. It might be helpful to take a look back at this section if you were doing your homework later. Definitionally. So if we go back here then, I'm going to go do a little bit more with this. So the next section, as you can see here, is interpreting bivariate tables. So basically now that we've practiced taking a look at the basic characteristics, we've looked at their definitions, this is where we're going to take a little bit deeper look. So like I said, this one's a little bit more, this is particularly important because it starts to look a lot like the work you will actually be doing for your own research projects when we're looking at the variables ourselves from the GSS, SPSS data we looked at while we were in class. Okay. So let's take a look at this. So looking at the bivariate relationship, I want to emphasize this word here, relationship. The reason we're emphasizing that is basically any sort of analysis that we're going to be doing, like any bivariate table, is always emphasizing the relationship between 2 things. So for instance, in this next section, we're going to be looking at church attendance and views on abortion. So we're looking at the relationship between these 2 variables. So, and we'll take a look at the chart in a second. But there's going to be 2 parts we'll look at here. 1, the research question that the person was looking at, and 2, the pair of variables that they used to analyze that. So the initial research question was, and I'll just reading from this section, are views of abortion related to church attendance. The working hypothesis is that church attendance would be positively related to pro-life views. So if you were researching this, for instance, some of you were interested in views on abortion and women's rights in your own research for our class. If this is something you're interested in, they took a look at two variables, and these are actually from the GSS data. For one, here's the research question they asked. Please tell me whether or not you think that it should be possible for a pregnant woman to obtain a legal abortion for any reason. And the second one was, how often do you attend church? So these are the two variables they took a look at, and they converted it to this table. So here's what this will look like in a table form. So you can see here's the bivariate part, variable 1 and variable 2. Church attendance and views on abortion. So from this chart, what sorts of things can you see? What sorts of relationships can you see? So you start seeing then, it seems like, you may pause and just take a look at this chart to absorb it for a moment. But you can also start to see that in the yes column, for instance, that it seems like people that support abortion seems relatively the same between never or infrequently, but in this section is the one that sticks out. People that frequently attend church are much less likely to support abortion. Where if you go to the no column, again, never and infrequently, if you look at these two, they're the same. If you look at these two, they're pretty close to the same. However, this one sticks out. So you might start saying, if you were this researcher, you could make the argument that for people who frequently attend church, that there does seem to be a pretty strong relationship between whether you support abortion or not. And here, 26% of people support it, whereas infrequently and never don't really have much of an effect. So if you were to take this into the next steps, we're just going to kind of go to next steps here. If you were to get this chart when you had this research question, so for our research purposes, if you had the question of whether someone's views of abortion are affected by their attendance of church, and you looked at these two variables, and you produce this chart with our software, you might come into here and you might be able to start in your essay. This is your essay. You would actually, for instance, be able to argue, maybe introduce your argument something like, I'm researching people's views on abortion and seeing if church attendance affects that. I found in my research that for people who infrequently or never attend church, it doesn't seem to affect them much. But for frequent church attenders, it seems to greatly affect their views on abortion. And then you might go through and explain the chart that you got, and at the end conclude that based on my research and my hypothesis, I found that there does seem to be a church and abortion connection. This was your final paper. Okay. And we'll go through more of those examples as we go on. This is just kind of a way to run it through what research might look like. Okay. So there's another thing we could take a look at here. Okay, so here's the second thing we could take a look at. This is just kind of a descriptive thing, kind of a definitional idea. So you could basically characterize charts that you get from SPSS as either positive or negative. So it's basically just looking at, again, we're looking at relationships, how they're related to each other. This is, again, pretty much any sort of data research we're doing here is always going to be looking at relationships. So one of the types of relationships we could use to describe how two variables are related to each other is a positive or a negative relationship. So I'm going to go through the definitions here and then give you two different examples. So positive relationship is when variables vary in the same direction, whereas negative relationships vary in opposite directions. Okay? So positive relationships can, when both vary, when one goes up, the other goes up, or when one goes down, the other goes down. And with negative relationships, they go in opposite directions. So as one variable goes up, the other variable goes down. As one variable goes down, the other one goes up. So it doesn't matter which. The negative ones are always going to be in opposite directions. Positive ones are always going to be in the same direction. So let's take a look at two examples. Here's an example of a positive relationship. So the two variables in this bivariate table, willingness to pay higher taxes, willingness to pay higher prices, and the researcher put these two on the same chart. So you start seeing unwilling to pay higher taxes is here, to unwilling to pay higher prices is 91%, and that cell, 91%. And if you start looking at this direction, for instance, willing to pay higher taxes with willing to pay higher prices is 57%. Indifferent to pay higher taxes and indifferent to pay higher prices is 55%. So basically you could see, if we were to describe this generally, it doesn't have to be exact, but the relationship generally, as one goes down, the other one goes down. So to basically describe the relationship between these two, they're both going in the same direction. As one of them is as willingness to pay taxes goes down, so too does prices. So this is a positive relationship because they're going in the same direction, even though the direction is down. Okay. So similarly, here's an example of a negative relationship. So this one, they're looking at two different things, the bivariate, and this one is attendance of religious services and education level. So basically what they're trying to see is, as someone gets more education, what does their attendance to church look like? If you start looking here, let's look at this top one. So someone who never attends religious service and has no degree is 5%. Let's look a little bit further. So someone who never attends religious services is much more likely to have a university degree. So it looks like in this case is somebody gets more education, they go to church less. You can start seeing it all the way across the board here, right? So here, somebody with no degree, 66%, versus and 2 to 3 times per month. So people that attend the most have the lower education, people that have more. So essentially then, what we're taking a look at here is as somebody gets more education, they do less religious services. So that relationship is negative because they're going in opposite directions. So just as a quick recap, if you looked above, these are going in the same direction, so this is a positive relationship. This one was going in opposite directions, so this is a negative relationship. So basically, as you would see this in homework, it might just ask something like, describe the relationship between these two variables. Is it a positive or a negative one? And all you have to do is see what direction they're going. If one's going up and the other's going down, that's negative. Or another negative relationship could be as one's going down and the other's going up. As long as they're opposite, it's negative. And the other one would be a positive relationship. If as one went up, the other also went up, that would also be a positive relationship, going in the same direction. Okay. So that is one last characteristic. So the final thing. So other types of relationships. So again, our whole thing is about relationships, how are two variables related with each other. We've taken a look so far at positive and negative relationships. We've done general relationships. And now there's two different forms that we want to take a look at. And here, basically what this is called, and it's just looking at relationships. But this is a technique called elaboration. I'll do a run through what this looks like, but essentially what it's doing is it's really kind of like a check to see if we got it right. Like we had done in previous chapters, it's checking to see if we made the right assumption about how things are related with each other, and how certain we could be these two things actually are related with each other. Maybe here's one thing, and then one last thing. Look at here. It helps us eliminate spurious or randomness. So it'd be good to keep these terms in mind. You're going to be asked something like this on your homework. So by looking more closely, it helps us eliminate spurious or random relationships. So an example I like to give here is talking about, say you went outside and you saw a, so observation. You see wet ground outside. In your conclusion, it rained. So observation, you see wet ground outside. Your conclusion was that it rained. So if I were to pause here and then ask you, what other conclusions could you have come up with? Or is this the right conclusion? You might say something like whether it was sprinklers. Or it could be someone with a garden hose. Or someone spilled a bottle of water, etc. Basic idea being that how do we know we got it right? And the way we check that is by double checking other relationships and seeing if something else may have actually caused it. So that's all that this means right here. Spurious just means random. So the random relationship between wet ground and it rained, do we actually get that? Okay. So let's take a look at one of these examples. Here's one example. Okay. Actually a pretty good one. So this is one of the examples they come up with in the text. So for instance, so what if you looked at data about fire damage? You're like an insurance adjuster or something, and you notice this connection that the more firefighters there were at a fire, the more property damage there was. The more firefighters, the more property damage. So what might you conclude of that, right? So would you come to the conclusion then, as they do down here, that firefighters cause property damage? Would you say then that we can't allow firefighters to come to fires because they're causing more property damage? You know, is that what you'd come up with? Or might there be something else going on here? Okay, so this is an example of if you laid this out, you could actually come up with this relationship. And to check to see that this isn't random or a spurious relationship, you might look a little bit deeper. And that's what elaboration does. So let's take a look at this. So this looks complicated here, right? But basically what they introduce then is they take a look at this. Small fire versus large fire. So their conclusion is, or their assumption is, that what if the larger the fire, the more property damage it could cause, right? Versus small fires. Because then that might explain that there's going to be more firefighters at large fires versus small fires. Okay. So what they end up concluding is, they try to do a secondary chart here. You start seeing that yes, indeed, 70% of the time, where there's large fires, there's also many firefighters. Whereas when there's low property damage, there's also small fires. they start to come to the conclusion that rather than this idea of there being firefighters causing a lot of damage, it has something to do with the size of the fire. Okay, so this is a chart that they make, which isn't necessarily important for you to take a look at. It's more important for you to understand what the relationship is here. And maybe this over here makes it a little bit easier. So this is an example of a spurious relationship, meaning that the size of the fire happens to cause both the number of firefighters and the amount of damage. Okay, so rather than, as we saw over here, where they're saying the number of firefighters is the independent variable, and that's causing property damage, they were able to conclude rather that the size of the fire caused both things to happen. So this is the control variable, size of fire, is causing both the number of firefighters and the amount of damage. So this is an example of a spurious relationship, meaning that firefighters and the amount of damage just happen to come from the same cause. It doesn't mean one's causing the other, it just means both are happening. So this example of a random relationship, that these two things have nothing to do with each other. They just happen to come at the same time as the original cause. Okay? So spurious relationship means these two things right here are randomly caused by each other. They're not causing each other. Okay? So let's go take another look here. Okay. Just quickly run through that again. So spuriousness is random. So the way we want to check our work on this is to make sure that we're not coming up with a random relationship. Like with our example of rain, we observe the ground is wet and we think that it rained. Rather, maybe something else caused it. So the same thing here. The two observations, number of firefighters and property damage, they're arguing at first, if you don't look any deeper in this, they might come to the conclusion that firefighters cause the property damage. When in reality, if you control for the size of the fire, you find out these both happen from the one causal value variable. In this case, the size of the fire. This is spurious or random. Okay. So second one they take a look at is another type of relationship, and is another example of a type of mistake you might make in doing this sort of research. Let's take a look at that one. So in this case, this is another good one because it's actually using GSS data, and it's based on someone's research question. So this is also on page 249 of your text, if you have it. And they're comparing, in this case, the two variables are religion and attitude towards abortion. Okay. So one of the things that they do here, they ask the question, basically, if a woman wants to have an abortion for any reason, these are the reasons they have here. These are the reasons they have here, and these are the reasons a woman does not want to have the baby because they're very low income and can't afford more children. The woman does not want to marry the father. The woman does not want to have more children. But basically, does the woman support abortion? And what religion are they? Okay, so they found some interesting things. Let's zoom in on this. So this one is, if you just kept at those two variables, it is religious affiliation and whether or not they support abortion. So you start looking, is compare these two numbers here, Protestants versus Catholics, and what do we see? I think the first thing you note right off the bat is the big difference in percentages here. You can see that Catholics support abortion at about 10% less rate than Protestants. So you might come to the conclusion, if you don't go any deeper, that Protestants are more accepting of abortion, whereas Catholics aren't, and leave it at that. But what if there's something else going on here? And similarly here, if you look at this chart, if all you're looking at is Catholic versus Protestant, whether they support or don't support abortion, you could see that, yes, indeed, it seems to be pretty split among both of them. Okay. But the picture is more complicated than that. So the question that the researcher then ends up asking, what if family size, preferred family size, has something to do with this? So, and we'll take a look at this in a moment, but basically what they're going to argue is, what if it has less to do with whether a person religiously, like their religious doctrine, tells them to support abortion, and more to do with someone's family size? So that maybe if one group supports a larger family, they might be less likely to support abortion. And if that's the case, maybe it doesn't have to do with religious teachings, but more to do with family size. So let's take a look at two charts they have here. So one thing they do two versions here. It's preferred family size, and that compared to religious affiliation. And we can see that Catholics are much more supportive of larger families by almost twice the rate. And two or fewer children, Protestants are much more supportive of fewer children. So we can see, at least in this first chart, that Catholics prefer larger families. Okay. What about the second chart? What if they were to take preferred family size then, and not talking about religion, but whether people who support large families tend to support abortion? You start to see actually that it does seem to be people that support abortion also tend to support smaller families. Say two or fewer children, whereas people that have more than two children don't support abortion. So 50 versus 75%. Meaning that it seems like not only does, from the first chart, Catholics tend to support larger families, but no matter what religion you are, people that want more kids tend to be less supportive of abortion. Okay, so let's put this together. So what they're going to get at, and I'll show you the final chart in a second. This one's called an intervening relationship. So the first one we looked at with the firefighters was spurious or random. This one's intervening. So what they're arguing then is it isn't religion causing abortion support. Preferred family size is intervening. So someone's religion determines a preferred family size, and this affects their support for abortion. So it's not this first relationship. It's not getting the full picture. So we'll take a look at that. So here's a final chart that they put together that combines everything. So you start to see then, so they have religious affiliation up here, Catholic versus Protestant, and whether people support abortion based on family size. So just to kind of clear that up a little bit. So you can see here, preferred family size of two or fewer children. And it seems to be almost the same. So what you're essentially looking for here is that once you do something like this, once you add a new variable, is you want to start to see if that takes care of the difference. So now you start to see that no matter what religion somebody is, whether Protestant or Catholic, if they support having smaller families, they support abortion at about the same rate. And so you can see the same thing here. It's almost the same here as well. And down here. So preferred family size, smaller families. You start to see that these numbers are also about the same. So what you can conclude then is the way this kind of proves that there's an intervening relationship is that once you combine the variables with the intervening relationship, you start to see these differences disappear, suggesting that the support for abortion between Protestants and Catholics has less to do with religion and more to do with preferred family size. This is all basically to demonstrate again that we've got to be careful what sorts of conclusions we draw. Because in this case, we saw that if we just say religion causes or affects someone's support for abortion, we'd be wrong because we didn't look closely enough at intervening relationships. So just to suggest that we should be careful with the sort of research we do. So let's see. So let's do a few more quick definitions here to kind of summarize all this. So we saw in the original one, the religion was the original variable, and we saw that actually there was an intervening relationship because there's something that took place in between the two. In this case, it was support for larger families, which caused which affected the relationship. Okay, so, and this is just broadly, this is from a category called conditional relationships, meaning when a relationship changes depending on intervening conditions. So in this case, we saw that yes, religion was related with support for abortion, but this was conditional depending on what other variables we included. So broadly, you would still be right in saying that religion affects someone's support or not support of abortion. But you wouldn't be given the full picture in the conditional relationship of including the idea of someone's support for large or small families. Okay, let's take a quick look. So broadly, just a thing to keep track for when we're going through the work is to keep track of these sorts of definitions. So one, of course, with the last one, keep track of the word spurious or random relationships, and this is the firefighter example. And also in the homework, you want to keep track of things like conditional relationships, noting that if something was affected by an intervening variable, in this case, we had the intervening variable preferred family size. And one of the other things, other thing to keep track of too, is just keeping a look at when you're looking at these charts, because most of the work is going to be around charts, is to be keeping close eye on modifying these charts from the more raw version over here to the more refined version. And just keeping track, when you make these charts, to be sure that you have the accurate numbers, double check your work, and make sure you have the total columns in here. Because one thing I think I'm going to write down here, because it's very important, not even just for this section, is that always include the totals in both the rows and columns, as well as the grand total, or n. So basically just what I wrote here is just when you're making these charts, just always include the totals. What I mean by totals is the total in the columns and the total in the rows. And then the grand total is just the total, or the n, the total number of people. So those are going to be important later on when you're making these charts. Maybe not as much for this chapter, but for future chapters, you always need those totals because those are going to tell you, this is going to be what you're going to be able to do more complicated math with, is having these grand totals. So I will go ahead and stop here, and then you all could start the homework and take a look at all this. And I encourage you all to work in your groups and put your minds together to get these assignments completed.